Okay, so I've been noticing that in the 8.04 quiz that we're doing this week, a lot of people are struggling with number 4 particularly. Number 4 is 10 points out of 25, so it's very important because if we don't get it right, then essentially we don't pass the quiz. And there doesn't seem to be a lot of examples of number 4. So I want to kind of give you an example, kind of help you get started on how you should be thinking about this. Now, number 4 says create a polynomial with a GCF of 6. Rewrite that polynomial in 2 other equivalent forms and explain how each form was created. Now, to make my example different, I'm going to go with a GCF of 7 rather than a GCF of 6, but I will show you how I incorporate that number later on. Now, a good polynomial to go with that's pretty standard for us is a quadratic, where something that's in the form ax squared plus bx plus c. A, b, and c are just going to be numbers. So for example, we could have 3x squared plus 10x plus 2, right? I just picked some random numbers off the top of my head. That's a quadratic. But here's the thing. We don't want to use just 3 random numbers in our polynomial. We want to make sure that our numbers have a GCF of 7 so that every number is divisible by 7. And we want to make sure that we can factor in multiple ways as well. So don't just create, 3 random numbers to make your quadratic. Let's start, and you guys can start as well. Let's start with the a being 1. And oops, I didn't mean to zoom out there. And I'll explain why later. Okay, let's start with 1x squared, right? Now I want to figure out a b and a c. Now, what I want us to do is find 2 numbers that will multiply, because you remember solving this puzzle in previous sections in the other videos I showed you. I want to pick a c value that's going to be convenient to multiply to. So any c value will work. So again, don't use my numbers in the question on the quiz because obviously we'll know. So pick something else, but I'm going to pick a c value of 12 right now. Okay, plus 12. So when I do my a times c, since I picked that as 1, this number is going to be the same as my a times c, right? 1 times 12 will be 12. So I'm going to pick 2 numbers that multiply to 12. Now let's pick any 2 numbers that multiply to 12. I'm going to go with 3 and 4. 3 and 4 seem pretty nice, right? 3 times 4 makes 12. And if I use those same numbers to make the b value, 3 plus 4 is going to make the b value 7. So that means that I should have 7x here in the middle. So there, I've made, just from scratch, a polynomial. Remember, just to recap what I did, I decided, hey, let's make the a value 1 for now, because it's very, very simple. And I'll pick any number I want for c here, right? You could pick 12. You could, like I did, you could pick 9. You could pick whatever you want. I picked 12 just because I just felt like it, right? It doesn't really matter. It's any kind of number would work. But the thing is, you have to find 2 numbers that multiply to make that value. So if I pick 12, then I'm going to choose 2 numbers like 3 and 4. I could have chosen 6 and 2. I could have chosen 12 and 1. I could do that. But I chose 3 and 4 just because. It doesn't really matter. Any set of numbers will do. But I chose 3 and 4, which means 3 plus 4 makes 7. That's my b value. So that's why I have to put 7 there. Okay. If I had gone with some other numbers, like let's say, I made my number 12, but let's say I went with 6 and 2, right? 6 times 2 to make 12. Let's say I use those numbers instead. Then I'd use 6 plus 2, the same numbers, to make my b value. 6 plus 2 would be 8, and I would make my b value 8 rather than 7. But let's stick with my original one, right? I just picked 3 times 4 to make the number of 12 that I came up with. So 3 plus 4 makes that b value of 7. All right. Now, what I want to do is just multiply all these values by 7, because that's my GCF, it tells me it wants to have a GCF of 7. So if I multiply this entire thing by 7, I'll kind of be working backwards in the way of GCF. So if I multiply all those terms by 7, because I want my GCF to be 7, then this would become 7x squared. 7 times 7 would be 49, so that'd be 49x. And 12 times 7 would become, I'm always bad at remembering these, 84. So now, when I'm looking to write my answer, remember, I have to write a polynomial and two other equivalent forms. So this is going to be my original polynomial now, okay? So I'm going to start my original polynomial first form. It's going to be 7x squared plus 49x plus 84. And now I've already done all the hard work to make the rest of this very, very easy. So my second form is going to be if I took a GCF out of this, right? My GCF, I artificially made 7. Because remember, I multiplied everything by 7. So if I were to divide all of these by 7, right, my factored form would have the 7 on the outside, and it would just become the original polynomial I made, which is 1x squared plus, let me write this a little bit better, plus 7x plus 12, right? So remember, I'm kind of doing all the steps up here to sort of create a problem that's going to be very easy to factor. And so now I've created it, and so now I'm just factoring it. And I already know all the steps of factoring because I made these, right? So there's my second form. It just factored the GCF out. And then my third form will be factoring the last part of this remaining. So remember, we already kind of did this because we already hand created that artificial factor for it. So if I were to factor, of course, this part, we should already know the answer. But, you know, you're looking for two numbers that multiply to make a times c, and you're looking for two numbers that add up to make b. But a is obviously 1, c is obviously 12. Remember, we chose those for a reason. 1 times 12 makes that 12. Do you see how we're kind of going backwards to what we created earlier? The b value is 7. So we're looking for two numbers that multiply to 12 and add to 7. Well, remember, we already did that. We already picked those numbers originally so that we would have them now for later on. So it's 3 and 4. And since my a value is 1, remember how I told you, let's make the a value 1 because it'll make things easier. That means this will factor very simply into x plus 3 and x plus 4, the two values I created here. So I'll have 7 and then x plus 3, x plus 4. There's my final factored form. Okay. So we kind of thought ahead. We sort of make a math problem ourselves. That's kind of the trick to this. So when we're making a math problem, we want to consider all the things we're going to have to do, like the a and the c, the b value, the GCF. And I did all that at first so that when I came to writing my three factored forms, first factored form, second factored form, and final factored form, right, I have my work. As far as explaining, I would write my explanation for this. I would say factored out GCF of 7. And then on my final form, my final explanation for this one, I would say factored x squared plus 7x plus 12. There's a method called product and sum. I don't think I mentioned that in the previous videos, but it's kind of what we just did, you know, solving the puzzle where we have two numbers that multiply to 12 and the same two numbers that add up to 7. This is called product and sum because you're finding a product and a sum. So you can say factored that x squared plus 7x plus 12 by product and sum, right? And if you want to be more specific, say 3 times 4 equal to 12, 3 plus 4 equal to 7, right? So that could be your explanation that you would write out. So that's essentially how you would do that question on the quiz. Obviously, you're not going to use this example because your example, first off, wants a GCF of 6, not a GCF of 7, but you can start from scratch the same way, okay? I'll leave you guys there with that video. If you want to stick around, I'll do one more example if you feel like you want to see it through again. But otherwise, you can just end the video here and try that quiz question yourself. But I will do one more example. Let's do a GCF of, let's say, 5 for this one. So remember, I think it's a good go-to to go with the quadratic. So remember, let's make a 1 for now, 1x squared. And let's not do bx, but let's find the c value first. So again, you can pick any c value you want. Let's go with I usually like to pick an even number, so let's go with 10. I'm just picking that number randomly. Now, what I want to do is, since a is 1 and c is 10, that obviously means that a times c, or 1 times 10, is going to equal 10, which is why I've already put that 10 there. Now what I want to do is I just want to pick two random numbers that multiply to 10. You can go with 10 and 1. You can go with 5 and 2. I'll just pick 5 and 2 here. 5 times 2, right? Which means let's use the same numbers down here to add. 5 plus 2 makes 7. So that means my b value is going to be 7, just like the last problem. So I'm going to have 7x there. Okay, so again, I pick a random c number, okay, to use here, and then I pick the any two numbers that multiply to make that value. As long as you use the same numbers up here as you use down here to get the correct b value, you should be fine. So I've created a base polynomial, but remember, because my GCF is a factor of 5, right, let's take everything here and let's multiply it all by 5. So I have a polynomial where everything is divisible by 5. Because it's not divisible by 5 right now, but once everything is multiplied by 5, then everything can be divided by 5. So that would mean that the first term would become 5x squared, the second term would become 35x, and the last term would become 50. And so now this is my first polynomial. This is my starter polynomial. So to write two equivalent forms, we just factor this polynomial. So the second equivalent form would be factoring this first one by GCF. Now, obviously, we know that every term is divisible by 5 since we just made every term multiplied by 5. So if you could factor out that 5, and your new factored form would be 5x squared plus 7x plus 10. And my explanation would be factor out GCF of 5. And then my final factored form would be to factor out the x squared plus 7x plus 10. Remember, we already kind of set that puzzle up before. We know the two numbers that add up, or I'm sorry, multiply to make 10 and then add up to make 7, the b value, right, are 5 and 2. So, I mean, you can refactor this if you want, but you've already done it because you've made it from scratch, right? You're looking for two numbers that multiply to make a times c. A is clearly 1. C is 10. 1 times 10 is 10. And same two numbers that add up to make the b value, which is 7. Again, we've already done this because we made this from scratch earlier. 5 times 2 is 10. 5 plus 2 is 7. Which means, again, since my a value is equal to 1, I can apply my shortcut. And I know this factors into x plus 5, x plus 2, because of the 5 and the 2. So my final factored form would be 5, and then x plus 5, x plus 2. And I would say factored, as my explanation, factored by product and sum. And then you could be more specific in your explanation just to say, hey, you know, I did that because I knew 5 times 2 equaled 10, and 5 plus 2 equaled 7. And that's how your answer would look online when you type in your answer in the quiz. Now, just a heads up, we are very aware of copy and pasting. We've seen it from a few submissions already. If you do copy and paste, if you find someone else's answer and you copy and paste theirs, or if you are just going online and finding something and copying and pasting it in, you will not be receiving credit for it. If it happens again, we are, calling home about it. We are going to let people know, the administration know about the attempts at cheating. And you won't receive any credit for it. So be mindful of that. Don't dig yourself into a hole. It's not very hard, I promise you, for us to see the people that copy and paste. Please just take this video seriously. You guys can handle this stuff. Don't try to take any shortcuts because it will come back to bite you. So just be aware of that, okay? I don't want anybody getting into that kind of situation. So if you need any more help, just let me know. I'll see you guys later. Good luck on the quiz.